We'll take a look now at an example of applying synchronized methods, and we'll see how this is going to fix the race condition in the buggy queue that we had looked at before. As we'll see, however, using synchronized methods only provide a partial solution. They don't go as far as to solve the real hardcore underlying problem. So what's a partial solution? It's something that's not fully complete, much like the famous Crazy Horse Memorial, which sadly will probably never be complete, but that's pretty cool, but they never quite got around to finishing it. So if you take a look at the busy synchronized queue example that's in my GitHub repository, you can see there actually is a way to do this. And this is kind of fun. This is one of those neat examples that times how long it takes to do the example, so you can see whether it's good or bad. So this is actually an example that works from a correctness point of view, but it's actually a little bit inefficient for reasons we'll see in a second. The synchronized queue is modeled on the array bounded queue that we looked at before. The busy synchronized queue implements bounded queue just like buggy queue did. Here's the sequence diagram. That looks very similar as well. So we make a test thread. We make a busy synchronized queue. We make a producer and consumer thread. We start them and they start to run, and the producer thread adds stuff to the queue, and the consumer thread pulls them out of the queue. And as you'll see, this test actually works correctly. It doesn't blow up like the buggy queue did, but it's really inefficient because it's busy waiting. When the queue is full, the producer thread will spin, trying to put stuff in, and it'll keep failing, but it'll keep trying over and over again, sort of, obsessively. And likewise, when the queue is empty, the consumer thread will just sit there and spin, trying to pull things off the empty queue, and it won't crash. It just isn't very efficient. So let's take a look and see how you could implement this stuff. We're going to have the synchronized method. We're using a synchronized method here as opposed to a synchronized statement. It's just easier. So now offer and poll are synchronized, so only one thing can be in there at a time. And this, even though this is correct, right? In other words, this code will work, it actually could be a downside because it's possible to have more clever implementations for implementations of queues that are based on linked lists. Why is that? Because if you have a linked list, using a queue as a linked list, you have things that put stuff at the head and at the head of the queue, insert and remove, and you have things that put stuff at the end of the queue, either putting it or removing it. And if you want to play your cards right and you're willing to spend a little bit more time to be clever, you could actually have a lock for the head and a lock for the tail. And so as long as the queue has more than one instance in it, one element in it, then you don't actually have contention when you add and remove things. So it's only if the queue is empty or has one item that you have any contention. So unfortunately, using synchronized actually underutilizes the available parallelism because of the implementation of using a linked list. So even though this works, it's not necessarily the right way to do it. And in fact, if you look at the array linked queue implementation in Java, you'll see that they actually have a pair of locks, one for the head, one for the tail. And they treat them independently for the most part. Adding the synchronized keyword has two effects in Java. The first thing it does is it makes sure that you can't end up with race conditions, because when offer is running, poll is not running, and vice versa. So each of these methods executes atomically from the point of view of the effects that they have. When someone's in the critical section, nobody else can be in there. And the second thing that happens, and this is something I'll talk about in a second, there'll be a video coming up shortly on happens before relationships. There's a happens before relationship that is enforced by using synchronized, that basically means that after this method finishes, when the closed curly brace is logically hit, that will flush out any changes to the state in such a way that other threads that come along and offer or poll will get a consistent view of memory. So we'll talk more about happens before later, but that's basically the idea. You're making sure that the synchronized keyword makes sure it flushes the caches properly so people see consistent memory utilization. Okay, so that's the end of the example, very simple example.